Think about it. July 1969. The world is watching as Apollo 11 makes its descent to the moon. It was an incredible moment for humanity, no doubt. But it was about so much more than just planting a flag. The real prize was bringing back the first ever pieces of another world to finally start answering questions we've had for millennia.
And this is the view they had looking back. Our entire planet, just hanging there in the blackness. It's a perspective that completely changed how we see ourselves, right? But as mind-blowing as that was, their eyes soon turned back to the alien ground under their feet. The real work was about to begin.
For all the spectacle and the historic firsts, the heart of the mission was discovery. What secrets was this silent, gray world actually holding? What were the very first things we learned? Okay, so this is what's so cool about what we're digging into here. We're not looking at 50 years of lunar science with perfect hindsight. Nope. We are going straight to the source, the Apollo 11 Preliminary Science Report. Think of this as the first draft of our understanding of the moon, written by scientists while the samples were literally still being unboxed. This is science in real time.
So, before any labs or microscopes got involved, the very first data came from the most sensitive instruments on the surface, the astronauts themselves. So what did they actually see?
That famous boot print wasn't just a symbol. It was basically the first soil mechanics experiment on another world. Neil Armstrong and Buzz Aldrin described the surface as this fine, powdery, almost graphite-like substance. It was soft enough to leave these perfect prints, but also firm enough to give them really good traction.
And what about the color of the moon? In their own words, it was pretty much without color. They saw this whole landscape of grays, from a lighter, chalky gray when they were looking towards the sun, to a much darker charcoal gray in other directions. Up close, they said the soil was like fine pencil lead.
Now here's where things got kind of trippy. The lunar environment played tricks on their minds. On Earth, we have an atmosphere that creates haze, which helps us judge distance. The moon has none of that. So with no familiar objects for scale, their depth perception was completely thrown off. Boulders that looked like they were just a short walk away were actually miles off, while the flag they had just planted seemed close enough to touch from inside the lander.
Okay, so building on what the astronauts saw, let's now look at what the scientists could measure. We're going to turn our attention to the soil itself, which has a very specific name.
It's called the regolith. And you've got to understand, this is not soil in the earthly sense, like in your garden. It's a blanket of debris that's been pulverized over billions of years by countless meteorite impacts. Everything from the finest dust to large rocks is all part of this regolith.
And this illustrates one of the first big physical discoveries they made. The top few inches of the regolith were soft and loose. But when the astronauts tried to push a core sample tube in or scoop any deeper, they hit a much, much denser and more compacted layer. Getting a deep sample turned out to be surprisingly hard work. Once those precious rock boxes were back on Earth, the real detective work could begin, because locked inside these gray rocks was nothing less than the chemical history of the moon. And the first chemical analyses were absolutely stunning. Now, the basic elements were the same ones we have on Earth, but the proportions were totally different. The lunar rocks were packed with elements like titanium and zirconium, stuff that solidifies at really high temperatures, but they were seriously lacking in things like sodium and potassium. So the crucial point here is the moon wasn't just a piece of the Earth, it was cooked differently. And then came the big one. Using potassium-argon dating, scientists measured the age of the rocks they brought back, and the result? 3 to 4 billion years old. To put that in perspective, that's older than almost any surface rock on Earth, where everything is constantly being recycled by tectonic activity. In one fell swoop, Apollo 11 proved that the moon is an ancient, geologically preserved museum of the early solar system. But science is never just about confirming what you expect. The best parts are the surprises. And this preliminary report was filled with genuine mysteries, things that nobody saw coming.
So you have to wonder, right? What was the single most bizarre thing the astronauts noticed, just sitting there as they explored the surface?
It was this. Inside several small craters, they saw these strange glassy patches, which they described as looking just like drops of solder. They weren't everywhere, only in these very specific spots. The close-up camera they had confirmed it.
The very tops of small clumps and soil particles looked like they'd been flash melted right in place, creating this glazed surface. This wasn't like glass from a meteorite impact. This was something different, something that had happened right there.
So the scientists in the report put forward a really radical theory. What if, sometime in the last 100,000 years or so, the sun had unleashed a superflare, a blast of radiation so intense that it literally melted the top layer of the lunar soil? This was a wild first-blush hypothesis, but it really shows just how strange this finding was.
Another huge surprise came from the seismometer they deployed. Here on Earth, our planet is constantly humming with seismic activity. The moon, by contrast, was profoundly still. The background noise level was thousands of times lower than Earth's.
And the implication was immediate and profound. The moon doesn't have tectonic plates. There's no great geological engine churning away inside. The report confirmed what many had suspected. The moon is a geologically quiet, if not dead, world.
So, after those first few frantic weeks of analysis, what did the moon's first report card look like? What were the big headline findings?
Okay, let's break it down. The moon is ancient, a relic from the early solar system. It's chemically unique, formed under different conditions than Earth. Its soil is soaked with particles from the solar wind, collected over billions of years. Critically, there was no evidence of life, with organic material at less than 1 part per million. And finally, it is geologically quiet, a world basically frozen in time.
But perhaps the most important finding of this first report was just how much more there was to learn. The glazed rocks, the unique chemistry, the sheer age of it all. These preliminary findings set the stage for decades of research. They answered some of humanity's oldest questions, and in doing so, opened up a universe of new ones.